Hi guys, welcome back to another tutorial. Today we're going to start some lessons on what system of equations are. Okay, so we're going to look into that a little bit. So this is not a system of equations. Okay. This is also not a system of equations. This is a system of equations. So is this. And this is also a system of equations. So the question asks, what is a system of equations? Well, what do all these things have in common that these don't? If we look at those top graphs, you notice that there's something very different about the top three than there is about the bottom. What is that? Well, on the top, each of these show two or more graphs. The ones at the bottom only show one. And that's one of the foundations of what a system of equations is. On a coordinate plane, a system of equations shows two or more graphs. As you can see on here, we have two parabolas. That would be a system. On here, we have two lines. That would also be a system of equations. On here, we have a circle, a parabola, and a line. So there's three equations working here. That's also a system. Okay, these you can see we only have one graph. You need at least two graphs in order to have a system of equations. So a system of equations includes two or more graphs that share the same coordinate plane. This is an example of a system of linear equations. Why is it a system of linear equations? Because this system only includes lines. So a system that only includes lines, it can have more than two, it can have three, four, it could have any number of lines, but a system of linear equations that only has lines is a system of linear equations. On the other hand, this is a system of nonlinear equations. As you can see, there are no lines here. Now, it could have a line in it, but if it has anything other than a line included, then it's a system of nonlinear equations. So, for instance, if we had a parabola or two parabolas and a line in there as well, it would still be called a system of nonlinear equations because it's not exclusively lines. So here's another way we can identify a system of equations. If we look at all three equations here, and remember the equation in red refers to that red circle. The equation in green refers to the parabola, y equals x squared. That's the parent equation and the parent graph for a parabola. And this linear equation, y equals 2x. They all have something in common. And this is a little hint down here. What do you notice about the variables? Well, what they have in common is that all the equations in the system use the same variables. If we look here, we've got xy, xy, xy. So in each case, we're using the exact same variables. And that's the other thing that defines a system of equations. We can look at the equations and see that they all have the same variables, or we can look at the graph and see that there's more than one graph sharing the same coordinate plane. Either way, that constitutes a system of equations, whether we look at the graph or whether we look at the actual equations. So what is a solution or solutions of a system of equations? Well, if we look at these two equations or the graphs of these two equations, we can see that there's 2 points of intersection here. Okay, those are the solutions to this particular system. And you can see there are 2 points that are shared by both these graphs. Okay, so those are solutions to this system. Okay, now if we look at the equations of those two systems, the linear equation, or I'm sorry, the parabola, which is the quadratic equation, if we put in the x, we should get the y out. So if we put in, this is the equation for this particular parabola, x squared plus 1. If we put in 2, we get 2 squared plus 1, which is 5. So when we put in 2, we get out a 5. Now let's look at the linear equation. The equation for this linear graph is y equals 2x plus 1. Once again, if we substitute in the 2 and evaluate it, we get 2 times 2 plus 1 equals 5. So you can see when we put in 2, we get out 5. Same thing here. When we put in 2, we get out a 5. So that's a common solution. And that's what the solution of a system of equation means. That every graph in there, at some point, the point of intersection, that's a common solution for any equation that meets at that point. So how many solutions does this system have? Well, this system has one solution, and it's located at 1, 2. So we know that that's a common solution to the blue line, and it's a common solution to the red line. That point is part of both those lines. So what is the solution for this system? Your task is to write the equations for these lines, then evaluate both to verify that this point is a common solution.